Hello everyone and welcome to Acquisition Science. Today we're going to talk about orbitals. Now, in the previous lessons that I have taught you, I've taught you about electron shells. Well, this is a more advanced version of this, where the electron shells talked about the structure of the shells outside of an electron. This is talking about the energy levels associated with those electrons. Now for this, we need to classify certain parts of our periodic table and give them a certain symbol. For instance, everything that's in the 1 and 2 column will be given the letter S. This helps us to clarify that they are from the first or second column. Now, our second section happens to be from the 3 to the 0. We classify this entire section as P's. Notice how I have not highlighted helium on that one. Our last section that we have, well, our second last section is our transition metals. So this one lovely in the middle, we classify those as our Ds. Now, unfortunately, this periodic table is one that I took from the QCAA, and you will notice that it does not have the lanthanides or the actinides down the bottom here. They have a classification of F. But today we're going to focus on this. Once again, I will point out that helium and hydrogen this time are both not classified. That's because both of these are actually in that first 2 column and should both be classified as S's. Now this is all important for our classification because it tells us how much energy is needed per. You will notice that the S column only has 2 spots. That's because only 2 electrons are required for our S, where our P takes up 1, 2, 3, 4, 5, 6. So 6 electrons are needed to fill up our P's. Whereas our D down in the bottom here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 spots in our D. This is all important and can actually help us to know what structures are going where and how high we are going in our energy levels. Now, someone once explained it to me like a computer game in that you progress up certain levels. So for that, you kind of need to start at level 1. Level 1 being these first 2 up here, our hydrogen and our helium. So in order to progress through that, we need 2 electrons in order to clear those levels. That means 2 energy are needed to progress up. Once you move up, you get to level 2. Level 2S requires 2 energy as well. Therefore, up until this point, we've spent 4 energy. From level 2S, we can progress to level 2P. This requires 6 energies. Finishing this one and filling up this gap unlocks 3S. We can actually progress up to level 3. Once again, this is worth 2 energy. And we can then progress to 3P. 3P being worth 6 energy. However, at this point in time, it actually unlocks level 4S, meaning that we can spend the 2 energy that is required to unlock 4S before we have to spend the full 10 energy to unlock 3D. Now that 10 energy does have to get used because we need that in order to unlock 4P. This is shown in a much easier form that you probably will see in the textbook as this. The simplest way is write them all down in an order, 1S being that first column, so hydrogen and helium, only 2 spots. Second one, well, we've only got our 2S and our 2P, so we progress with this line. So as we're going down, you can see that the arrows are pointing in the direction of the order. So we'll start off with 1S, 2S, 2P, 3S, 3P, 4S, 3D. You can see that 4S is arriving before 3D. That's because, once again, that 3D is worth 10 electrons. So a lot of energy has to go in to fill those gaps. It's probably a little bit of a shorter cut to fill up that 4S first. Once again, 3D will help you unlock 4P, which helps unlock 5S. All of these will progress before we get to 4d. And obviously here you can start to see those F's coming in. Remember, those are our lanthanides and our actinides. Lanthanides and our actinides. Sorry about that. Best way for us, however, is to put this into practice. Our first one that we are going to get today is this. Now, how would I structure and how would I put an appropriate amount of levels of energy in for something like oxygen? Now, oxygen has an atomic number of 8, therefore we know that there are 8 electrons in our atom for our oxygen. That means we've got 8 energy that we can spend on our map here. This requires us to get a bit of a pen, and here's how we will fill it in. So because I've got 8 electrons, I have 8 energy, and we start by putting 1 in an upwards arrow. That's 1 energy. The second energy will get spent double checking to make sure. So we put both up and down before we can progress up. 2s, well, I've got 1 more, 2 more. At this point, I've got 1, 2, 3, 4 electrons used. This progresses us up to 2p. Now, p is a little bit tricky. Because there are 3 little sections for p, we actually want to fill in a gap each time. So we actually fill in the up arrows first. This being 1, 2, 3, 4, 5, 6, 7. Notice how I have filled up my up arrows before we progress with our down arrows. That means my 8th electron will end up filling up this gap. At this point, I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. I have now run out of electrons. Therefore, we say this orbital is now complete. In fact, we filled it up to a point. Now, at this point, you will notice that the top level actually doesn't have all pairs. That's because we say it is actually paramagnetic. That means it weakly attracts others. You can see because it's got 2 vacant spots. Now, how we actually write this in an exam is a little bit different. We kind of require us to fill in the gap down below. Because 1s is complete, we write 1s, and we actually put it to the power of 2. We highlight how many energy we used in that moment. Notice how we did the same for 2s. So we place 2s with the power of 2. Now in 2p, we had 1, 2, 3, 4. So our power would only be to the power of 4. And essentially, this would be the answer that you write in your test. Now let's give it one more go, this time being magnesium, obviously a little bit bigger. So let's have a look, see if you can work it together with me. Try pausing the video and giving it a go. I'll wait for a moment. Good, now we're back. So, as I said, up on the top there, we've got our atomic number. The atomic number is 12. Therefore, we have 12 energy we can spend in this area. Once again, we do our up arrow first in our first row. I have to fill this up before I can progress up, and therefore my up arrow has to have a down arrow with it before I can move up. That brings 2, 3, 4. Once again, up arrow before the down arrow. I've now filled in this spot, and I've now filled in this spot, which means I can now progress up to my 2p level. Having only used 4 means I've still got 8 left. So I can go 1, 2, 3, 4, 5, 6. At this point, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At this point, I actually have an extra level, which means I do need to put my progress up. Once again, at this point, we look at this chart and we know that the next one up is 3s. which means I need to put in a spot for 3s. 3s taking up how many spots? Well, let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Notice how we have now used up all of our energy, so all the electrons that we have, and we've filled up all our spots. This is fantastic because there are no spare parts. We actually call it diamagnetic. Diamagnetic means that there are no vacant spots, which means it kind of weakly repels other elements. Now I say that weakly because there's other factors that come into play. How we would write this answer in the test, well, we would write 1s first. Remember, there's 2 spots. 2s would be the next one that we write. Remember, power of 2 because there's 2 spots. 2p would come next. And we've got 1, 2, 3, 4, 5, 6 spots. The next one up would be 3s. And this would have 1 and 2 spots. And there you have it. That would be your answer for magnesium in the exam. Now let's do it with one that's in our transition metals, because right at this point we've picked on one from this side, we've sort of had one from that side, so let's pick on one that's a lot bigger. So here we're looking at iron. You notice how I've set up quite a few spaces for this. That's because we've got 26 electrons that we're going to be playing with. I know that because of that top number there, not being the smaller of the 2 numbers, that being 26, the atomic number, this being my atomic mass. We're focusing on that atomic number now, which tells us exactly how much energy we can spend and how many arrows we can draw on our diagram here. So let's kick it off. We got 26, so 1, 2, 3, 4, 5, 6, 7. Remember, I'm doing all of my up arrows before the down arrows. 8, 9, 10. Once this one is progressed, we look at our chart and we're going from 2p to 3s. So 3s comes into play. We go 1 and 2. At this point, 2, 4, 6, 8, 10, 12. We've still got plenty to go. I've finished my 3s, which means I can progress to the next one over, which is my 3p. So we go up arrows first, followed by the down arrows. Now we're having a look. 2, 4, 6, 8, 10, 12, 14, 16, 18. So I still have 8 left that I've got to place. So once 3p is done, we know that 3p follows our transition to 4s. So I'm moving over here. There's my 1 and 2, meaning that I've got 6 left over for here. We can double check that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I have 6 to place in my 3D column. We know that 3D is next because this arrow has run out in 4s and we're progressing to the next one over. Essentially, we've now unlocked 3D. 3D needing 6 spots, so once again, we start with up arrows first. So 1, 2, 3, 4, 5, 6. We have covered all of our 6. Having a look now, you can see there's vacant spots there, so we know it's paramagnetic on this one. But now we've got to fill it up, actually answer our question. So once again, we're going to fill out down the bottom. We have our 1s has 2 spots. We have 2s, which has 2 spots. We have 2p that has 6 spots. We have 3s that has 2 spots, 3p that has 6 spots, 4s that has 2 spots, and 3d that has 1, 2, 3, 4, 5, 6. 6 spots. Now, setting it up this way is okay, but we actually have a bit of a shortcut based on the fact that we can actually use our periodic table to demonstrate some shortcuts. Now, if we look where iron is in my periodic table, we can actually take a shortcut to the most previous noble gas. Argon being the previous gas in this one, so we count backwards, and that would meet us down to the closest one, which is 40 from 56. This means that we can actually take a bit of a shortcut. We can say, hey, start off at argon and then add the following. Here you can see I've taken a bit of a shortcut. I've missed out all of my 1s, my 2s, and the starts of my 3s. Reasons for that, if we actually have a look, 2, 4, 6, 8, 10, 12, 14, 16, 18. If we go have a look at argon, argon sits on 18 electrons. Therefore, we know that once the P's are filled up, we've actually come up to a point of a noble gas. So if my P has been filled up to a noble gas, I know I can take a shortcut from there, cut that part out, and just show you what is excess of that. In this case, I've got my brackets AR for argon, saying, hey, start at argon and add 3D from there, and 4s, which is a little bit of an addition. Now, I will carry on this in the next lesson. We will talk about how this is different for ions, but for now, I want to thank you. Have a good day.